Tests of divisibility of certain numbers. Without actually dividing the number, we can find whether the given number is exactly divisible or not by a given number. This is called test of divisibility of the number. For doing this, we have to find out the patterns in the multiples of the numbers as described below. Divisibility by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Test of divisibility by 2. A number is exactly divisible by 2 if its ones place digit is 0, 2, 4, 6 or 8. For example, each of the numbers 12, 18, 20, 64, 86, etc. is exactly divisible by 2. Test of divisibility by 3. A number is exactly divisible by 3 if the sum of its digit is exactly divisible by 3. For example, consider the number 549. Sum of its digits is equal to 5 plus 4 plus 9 equals to 18, which is exactly divisible by 3. Therefore, 549 is exactly divisible by 3. Test of divisibility by 4. A number is exactly divisible by 4 if the number formed by its digits in the tens and ones place is exactly divisible by 4. For example, consider the number 7176. The number formed by the tens and ones digit is 76, which is exactly divisible by 4. Therefore, 7176 is divisible by 4. Test of divisibility by 5. A number is exactly divisible by 5 if its ones place digit is 0 or 5. For example, consider the numbers 90, 970, 7205 and 27105. Since the ones place digit of the given numbers are either 0 or 5, the numbers are exactly divisible by 5. Test of divisibility by 6. A number is exactly divisible by 6 if it is exactly divisible by each one of 2 and 3, which are also the prime factors of 6. For example, consider the numbers 48, 120 and 2316. Since the given numbers are exactly divisible by both 2 and 3, the numbers are exactly divisible by 6. Test of divisibility by 7. A number is exactly divisible by 7 if the difference between twice the ones place digit and the number formed by the other digits is either 0 or a multiple of 7. For example, consider the number 2982. Here, ones place digit equals to 2, so twice the ones place digit is equal to 2 multiplied by 2 equals to 4. Number formed by other digits is equal to 298. So difference equals to 298 minus 4 equals to 294, which is a multiple of 7. Therefore, 2982 is exactly divisible by 7. Test of divisibility by 8. A number is exactly divisible by 8 if the number formed by its digits in hundreds, tens and ones place is exactly divisible by 8. For example, consider the number 19,384. The number formed by hundreds, tens and ones digit is 384. It is clearly exactly divisible by 8. Therefore, 19,384 is exactly divisible by 8. Test of divisibility by 9. A number is exactly divisible by 9 if the sum of its digits is exactly divisible by 9. For example, consider the number 43,605. Sum of its digits is equal to 4 plus 3 plus 6 plus 0 plus 5 equals to 18, which is exactly divisible by 9. Therefore, 43,605 is exactly divisible by 9. Test of divisibility by 10. A number is exactly divisible by 10 if its ones place digit is 0. For example, consider the numbers 70, 200 and 4920. Since the ones place digit of all the given numbers is 0, so each of the given numbers is divisible by 10. Test of divisibility by 11. A number is exactly divisible by 11 if the difference of the sum of its digits in odd places and the sum of its digits in the even places is either 0 or a multiple of 11. For example, consider the number 4,95,803. Sum of its digits odd places is equal to 3 plus 8 plus 9 equals to 20. Sum of its digits in even places is equal to 5 plus 4 equals to 9. Difference of the two sums equals to 20 minus 9 equals to 11, which is exactly divisible by 11. Therefore, the number 4,95,803 is exactly divisible by 11.